We're going to continue discussing sequences today. The middle section of a movie theater has 40 seats in the first row, 38 seats in the second row, and 36 seats in the third row. Assuming this pattern continues, write out the first 7 terms in the sequence. So the first row has 40, the second has 38 and 36. So our recursive pattern here is to subtract by 2, 34, 32, 30, and 28. Now they're also asking us how many seats would there be in the 10th, the 20th, and the 100th row. We could find these by continuing the recursive pattern. However, our lives will be a little bit easier if we could figure out a formula. Now in our recursive pattern, we're subtracting 2 each time. So here we have to subtract 2 once, subtract 2 twice, subtract 2 3 times, 4 times, and so on. So somehow we're going to be subtracting 2 a certain number of times. The question is, what do we have to subtract 2 from, or 2n from? So for the first term, if I plug in a 1 for n, I need this to equal 40. So our blank spot here would be 42. 42 minus 2 is 40. For the second term, 42 minus 4 is 38. It seems to be working. So our 10th row would have 42 minus 22, or I'm sorry, 42 minus 20, so 22 seats. The 20th row would have 42 minus 40, or 2 seats. Now things aren't looking good for the 100th row here, but if we go with the formula, 42 minus 200 is negative 158. As we're doing these problems, you still have to use common sense. Even though the formula gives us this number, have you ever seen a row with negative seats? So we see here that this row doesn't exist. Well, our focus today is going to be on sequences of this type that follow this pattern, where you're continually either adding or subtracting the same number. When this is your recursive pattern, the sequence is called arithmetic. So every arithmetic sequence is going to have certain characteristics that we want to recognize. We see them a lot, and it'll help you out. So to start off with, let's take this sequence. What's our pattern here? 2 to 7, 7 to 12, 12 to 17. We're adding 5 each time. Let's graph it. Let's have our x-axis be our n's, our y-axis be our a sub n's. So when n is 1, a sub n is 2. When n is 2, a sub n is 7. When n is 3, it's 12, and 4 is 17. Look at that. We have a line. Each time we go to the next term, it's being increased by 5. So everything that we know about lines will have some kind of application here for our arithmetic sequences. Now one thing, every line has a slope. Remember, rise over run. So from this point to this point, you would have to rise 5 and run 1. So the slope of this line is 5 over 1, or just 5. Now I've seen that number before. Remember over here? To go from each term to the next, you're adding 5. So that is the change in the sequence. Now think about this. If I had erased this point, and I only gave you the first term and the third term, we could still find the slope by rising 10 and running 2. So that's something to keep in mind for a little bit later. Okay, so since we have a line, we know we could write the equation of the line as y equals mx plus b. M is the slope, B is the y-intercept. So over here, the slope of this line was 5. But what about the y-intercept? Let's see. Well, if I follow this back one, okay, that's not too helpful. So we have to go over 1, down 5. Over 1, so we're decreasing 5 from 2. So 1, 2, 3, 4, 5 makes the y-intercept negative 3. The equation of this line would be y equals 5x minus 3. So that means the formula for this pattern, a sub n equals 5n minus 3. Does it work? Well, our first term, 5 times 1 minus 3, is 2. Our second term, 5 times 2 is 10, minus 3 is 7. So we're good. Now just like I switched my variables here, the x and the y, we don't refer to these as slope and y-intercept because really we do not have a line here, we have a sequence. This number that we're adding each time is called the common difference. Common means it's the same, so all three of these are the same. Difference because it is the difference between these two numbers. 7 minus 2 is 5. Now, the y-intercept here, again, we don't want to have to make a graph every time we're looking at a sequence. So we could figure this out from the table. To get from 17 to 12, you subtract 5. From 12 to 7, subtract 5. From 7 to 2, subtract 5. So if we follow that pattern, 2 take away 5 is negative 3. I like to call this the zero term. And it's always the term that would come right before your first term. That is that connection with the y-intercept. Alright, so important information for us. A sequence is arithmetic if the differences between consecutive terms are the same. Remember, consecutive means one right after the other. And the nth term of an arithmetic sequence is given by this explicit formula. A sub n equals dn plus c. Now don't forget, this is your y equals mx plus b in disguise. Here, d is the common difference, also known as slope, and c is the zero term. Remember, you could think of that as the y-intercept. I'm going to give you a couple of non-examples, sequences that are not arithmetic. For example, 3, 6, 12, 24, 48. The pattern here is to multiply by 2. Now, even though the number is the same for each one, it's multiplication. In order to be arithmetic, it has to be addition or subtraction. So this is not addition or subtraction. Another one, 5, 7, 10, 14, 19. This time, we're adding 2, adding 2, adding 3, adding 4, adding 5. So it is addition each time, but the number is not the same. So this is also not an arithmetic sequence. Let's try a few examples. Everything on this page is arithmetic, and it's our job to figure out what the explicit formula is. Remember, sometimes that's also phrased, find the nth term. So example 1, what's our common difference? We are increasing by 2 each time. So our formula, a sub n equals, the common difference is 2 times n I have to find the 0 term, so if we back it up 1, that would be 8. Example 3, I gave you a couple more blank spots, but that's alright. We could still figure out what our pattern is. So for both of these, we have to add 5. A sub n equals 5n. This time we're going to have to back it up a couple times. So we get 2 and negative 3 for our 0 term. A sub n equals 5n minus 3. Okay, example 4 starts to get a little tricky. This time I did not give you consecutive terms. Go ahead, push pause, see what you can do with these next 3, and then come back and see how to do it. Okay, so here we have 3 to 19. So our terms increase by 16 here. But from 1 to 3, it took us 2 spaces to do that. So we have to increase 16 numbers in 2 spaces. So you're telling me here that the common difference is 8. So if we want to figure out what this is, 3 plus 8 is 11. 11 plus 8 is 19. So it fits. We can take a step back. 3 take away 8 is negative 5. So our formula, 8n minus 5. Now we could apply the same thing here. 12 to negative 14. Well, the difference between these two is negative 26. 2 to 15 is 13. So our common difference is negative 26 over 13, negative 2. Now let me show you another way that we could figure out the 0 term without having to count backwards. Negative 2n plus c. We know that when n is 2, the term is 12. So we could use this just like a point and plug it in here. 12 equals negative 2 times 2 plus c. Now we could solve this equation, find our 0 term, and we're done. So our formula, a sub n equals negative 2n plus 16. I'm out of time, so go ahead and try this one on your own. And to summarize here, for D, the easy problems, all you have to do is find the pattern. For the harder ones, do you realize what we are doing here? Finding the difference, and dividing them. That reminds me a lot of our slope formula. Now if you want to write the slope formula here, you can. But just remember the pattern. Subtract the a sub n's, subtract the n's, and you got it. To find c. On the easy ones, remember what we did? We just counted backwards by 1. There is a formula for it. That's how you like to work. A sub 1 minus d. And for the harder ones, plug in n, a sub n into the formula. A sub n equals bn plus c, and you will be able to find your c.